Today, let us discuss another method of transportation problem. That method will be least cost entry method. And to apply this problem, let us have an example. And this example will be before that. Let us see. Let us see. Uh, let us see. Okay. Okay. This is our transportation problem, and let us have the slideshow of this problem. Slideshow of the problem on a chart. Then slideshow. Yeah. Then this is the problem, and we will discuss this problem with the help of what? With the help of least cost entry method. So this is a problem. Question is differentiate an initial basic. Just a minute. We are to we are to we are red color, red color. Uh, so we have to find an initial basic feasible solution, and this is what? This is the question. This question is destination D1, D2, D3, D4, and this is the supply available there in different origins, and these are the demands of destination 1, destination 2, destination 3, destination 4. So destination 1, we can think what? In destination 1, there are suppose uh, 3 customers. In destination 2, there are suppose another 3 customers. Destination 3 also there are 3 customers. Destination 4, there are 3 customers. Means in destination 1, you can think that destination 1 is a part and there are 3 customers. The destination 2 is another part and there are 3 customers. Destination 3 another part. There are 3 the customers, and destination 4 there are means another part there are 3 customers. So to solve it with the help of least cost entry method, here least cost entry method, this method is also called matrix minimum method. Matrix minimum method means very simple to understand. Here we think of only the minimum costs. Minimum costs, say these values given here are the costs of transporting the values. Transportation cost from origin 1 to destination 1, origin 1 to destination 2, origin 1 to destination 3, etc. etc. So these are the costs. And well, first of all, we see the least cost out of all the destinations, out of all the and these customers, we see the minimum cost. Minimum cost, and we allocate the maximum possible items to that minimum cost. Maximum possible items means it is it is based on the requirement and the availability. So for that purpose, we we proceed to the next slide. Proceed to the next slide. Here we have written the values. It means we have simply copied the table, and now let us discuss this least cost entry method step by step. So first of all, we have prepared the blank table, and in the blank table, first of all, let us see which one is the minimum cost in the above table. So minimum cost is obviously 1. So we put here 1. Okay. After putting 1, now let us see. This is supply, means this is available, and this is what? This is the supply, means this 14 is the available what? 14 is the available items in origin 1, and in destination 1 we have 15 requirements. Requirement is 15. So out of this 15 and requirement is 15 and available item is there is 14. So how much we can maximum possible items can be given here is what that will be maximum possible items will be 14. So if we give 14 there, 14 items, all possible items available in origin 1 has been supplied to destination 3. So this part becomes 0. There is no item to be supplied from origin 1. And then uh, we this 15, out of these 15 requirements, 14 requirements have been given to destination 3 from origin 1. Therefore there will be one requirement still available. So then we since there is no availability in origin 1, therefore we can remove this row. So we ignore this row and we now from now onwards, we simply think of origin 2 and origin 3. Now, in origin 2 and origin 3, what is the minimum cost? There are two similar minimum costs, this 2 and this 2. This 2 and that 2, these two are similar minimum cost. So, out of these two similar minimum cost, we take only any one. Now, let us suppose we take these two. These two, so if we take these two, then these two so if we take these two, now we have to see what is the total possible items can be supplied, what is the number of possible items can be supplied to this destination 3 from origin 2, and what is the requirement is 1 and availability is 16. So we can give maximum one item there. So maximum one item is there. After giving maximum one item, then this part will be means there is no requirement in destination 3. And what will remain? What is the number of items available in origin 2 still? That is 50. So we have understood. That means again origin 1 it has already been finished. Then destination 3 this work has also been done. So now we can think only destination 1, destination 2, and destination 4. Destination 2, destination 4 means we think of what this origin 1, origin 2, then this destination 1, destination 2, then destination this we can this thing we do not think of this part. So this is 7. So 8, 9. Let us give some this part. No, okay. This and this and these three. We will think. These three we will. So the 8, 9, 7, 4, and 3. 8, 9, 7, 4, and 3, and 7, 4, and 3, and this 2. Which one is minimum? Here 2 is obviously minimum. Since 2 is minimum, therefore we bring this 2 to this cell, and this 2 after bringing this 2 from this cell, then how many items can be given from origin 3 to destination 4? The requirement is 4 and availability is 5. Therefore, we can give what 4 items to destination 4 from origin 3. So, since we have given all 4 items required in destination 4 from origin 3, therefore, this will be 0. There is no requirement is this in destination 4, and origin 1 will have still one item which can be supplied to another cell, another destinations. So this one done, then this time we have nothing to think of this destination 3 and destination 4. Therefore, what is to think? We will think only for destination 1 and those destination. That means now we think of what? Now we think of what? Now we think of destination one, this destination one and destination two, and origin one and origin two. So what are the items can be thought from origin two and origin? This 8 is there, this 9 is there, then this 7 nothing to think, then this 4 is also there, and this 3 is also there. So out of this, which one is the minimum? Obviously 3 is the minimum, therefore we bring this 3 from this cell to this cell, the corresponding cell, we bring this 3, and now we think this 3 is the minimum cost, and how many items can be supplied to this cell? Say available item is 1 and requirement is demand is 10. So maximum 1 item can be supplied to that part. Therefore, this becomes after supplying the remaining 1 item, this will become what? This will become 0, means origin 3 is now empty, and this D3 D3 will have still 9 items, the requirement of 9 items, and then we see origin 3 is also become empty, therefore we have only items available in origin 2. So we think of origin 2 and this destination 2 and destination 3. Destination 2 and destination 3 means we think of what? We now think of this 8, this 8 and this 9. See, after thinking of this 8 and 9, then we, what is the minimum cost here out of this 8 and 9? 8 is the minimum cost, so let us bring 8. Bring 8, then uh, what what is the maximum possible number of items can be supplied to origin 2? The maximum number of items can be supplied to destination 1 from origin 2 is what? It is based on the requirement and the availability. Availability is 15 and requirement is 6. So we can give 6 items. After giving 6 items, then this 6 item requirement of destination 1 becomes what? 0. No requirement in destination 1. Then only and available items means remaining items which can be supplied from origin 2 will be what? 9. So 9 items are still available, and there is only one destination 2 and only one origin. So one item has been, means only one cell is to be filled up. So this will be filled up. This is 9. We have brought this 9 from the above table, and this 9 requirement is 9 and availability is 9. So we can give this 9 to this cell, and by this way we can see the total. This availability means that this origin 2 has also become empty, and this destination 2 becomes means demandless, and means no requirement is there, and total supply and demand is also become 0. So this is the means this is the actual solution of this table, but we are to do what? We are to find, means this from this we have done the completion, means we have completed the table of least cost entry method. Now we are to find what? We are to find the initial basic feasible solution and the total cost. So initial basic feasible solution are, just a minute, this initial in these we have taken the table. Okay, before that let us have this, let us erase these things, these things, uh, so that we can easily understand, and uh, then this one and this one, and then we we write what the initial basic physical solutions means. These are the values. These values which are not written in brackets are the initial basic physical solutions in the corresponding cells. In the corresponding cells means this cell. What is the name of this cell? Origin one and origin destination three means we one three. So that will be written as what? That will be written as x1 3 is 14, then x2 1 is 6, x2 2 is 9, x22 is say this x22 is 9, x22 this is 9, we have written x22 is 9, then x23 is 1, x23 is 1, then x there is nothing, then x this one 3 and this one, so x3 2 x32 is 1 and this is x32 and this is x34 x34 is 4, this value, so that part is done. And to find the total cost, what is to do? To find the total cost, very simple. We simply multiply the cost per item and the total item. This values written inside the bracket is the cost per item, and values written in outside the bracket, these are the number of items. So total cost will be what? Number of item into cost plus number of item into cost plus number of item into cost. So 14 into 1 plus 6 into 8 plus 9 into 9 plus 1 into 2 plus 1 into 3 plus 4 into 2. Okay. And after simplification, we have got the values rupees 156. I hope you have understood, and if you like this class, then you please subscribe it, share it, and comment it. Thank you very much, and we can end the program and